Welcome back, everybody, and today we're going to be in chapter 13, which deals with measurement. We're also going to take a look at indexes. So measurement, as you will see, is the thing that we're trying to accomplish, and that's assigning usually numerical values to the items of interest that we're trying to study. So let's go ahead today and begin with chapter 13, which deals with measurement. Okay, everybody, welcome back, and today we're going to be looking at chapter 13, which deals with measurement and scaling concepts. Now, what do you measure? When you are looking at questionnaires and research and observation experiments and all of that, what information do you want to get from all of those devices and resources that you're using? Well, you want to be able to obtain data, and oftentimes you want to be able to measure that data. And a measurement, as you see here, is the process of describing some property of a phenomenon, usually by assigning numbers in a reliable and valid way. So you're using numbers to represent data so that you can get some type of numeric quality to that study. And then you have the idea here of concept, which is, as you see, a generalized idea about a class or object or attributes or process or something like that. Now here's some operational definitions. And here the first one we have is operationalization, which is the process of identifying scales that correspond to variance in a concept involved in a research process. Operationalization is really just finding the right scale measurement for that type of research so that you would get an accurate depiction or result from that finding. Scales are the devices that you use, and it ranges in values that correspond to different characteristics or amounts of a characteristic exhibited in observing a concept. For instance, a thermometer will give you a range of values. If your temperature is normal, you'll have 98.7 or something like that. But if you are running a temperature, it will give you a range of temperatures, numbers that you can look at to see how far from the norm you are and how sick you are. Correspondence rules. This indicates the way that a certain value on a scale corresponds to some true value of a concept. For instance, if I'm running a 100-degree fever, that value should register 100, or that thermometer should register a value of 100, and therefore, if I actually do have a 100-degree fever, then that's the correspondence rule that will be upheld. Now, constructs are concepts measured with multiple variables. Constructs are ideas that are very difficult to measure because they're not concrete. They're not tangible things. They're ideas and concepts. And this is how we get into trouble a lot of times, trying to quantify things that really can't be quantified. Happiness is a construct. How do you measure that? Well, you can have a visual kind of way of telling if a person's happy or not, but I've seen people who look like they were laughing but they were crying, and people who were crying and actually they were laughing. So you have to be very careful when you're dealing with constructs because they can be elusive and ambiguous. Now let's talk about the levels of scale measurement. When it comes to the levels of scale measurement, we see the word nominal. Now, nominal just means that we're assigning a number to the item or the object. If you look down at the picture of the football team, you see number 79, number 7, number 89. Now, this doesn't rank them as far as importance. It just identifies them. And this is what nominal numbers will do, nominal data. You also have what's called ordinal data. Now, ordinal data will rank these scales. It will rank that item or those items based on how they stack up against each other. For instance, in a race, you have first, second, and third place, and so forth. That would be ordinal data. It just ranks them in order of of arrangement and so forth. So they have nominal properties. Number 3 car, I believe that was Dale Earnhardt, when he was in NASCAR, when he was alive, he would be first. So you have an ordinal and a nominal number. Jeff Gordon may come in second. I don't know what his number was, and third, and so forth. So it is common to have both ordinal and nominal data. You see here with nominal, it just shows you the number 7. Ordinal shows you the places or the positions that these numbers have. Number 7, 1, number 6 placed, number 5 showed. Now interval, we're going to see that here in the next slide. It shows how far away each of these items are from each other, and those are intervals. You see here the 3 finished in different time intervals. Number 7 won, but number 6 placed, and number 6 was a second behind number 7. And then number 5 was 20 seconds behind number 6. So you see the different intervals that take place. And then you have ratio, which you see here number 7 was 1 minute and 59 2/5 seconds for a 1 1/4 mile run. So that's the ratio that took place for that time ratio for that number of miles. Now interval, again, we just mentioned that. It's just the differences in how they're spread out and the differences in the quantities of the concept. And it can have both nominal and ordinal properties. You saw that there were numbers which were nominal and ordinal. There was one who came in first, second, and third, but they also came in intervals of first, second, and third. Ratio is the highest form of measurement, and here you have all the properties of the interval scales with the additional attribute of representing absolute qualities, and one of those qualities is absolute 0. So what is important about this in ratio, you have 0 as a value, and the others don't have that. And they give you an example in the book about trying to sell wristwatches. The antique wristwatch was 1970s digital. It didn't sell for anything, so the value was 0. They had another gold-filled wristwatch that was made in 1950. It sold for $100. There was a vintage stainless steel wristwatch that sold for $1,000. And then they had an antique rose gold watch that sold for $9,000. And these are ratios. And you see also that in the last two, or the last one, there was one that was such a higher percentage, it was worth 9 times as much as the one before it. The one that was the most expensive was $9,000, which was 9 times more expensive than the Omega watch, which sold for $1,000. So that's your ratio. It was 9 times more. And then you had 0 for the antique watch. So you see these quantities or qualities being distributed and shown here in the ratios. Discrete measures. These are measures that can take on only one of a finite number of values. And when you are looking at tests that ask you yes or no, agree, disagree, neutral, these are discrete measures. Continuous measures, measures that reflect the intensity of a concept. And here you see a scale range. Rensis-Likert came up with what's called the Likert scale, and you've seen them and have probably filled them out time and time again. And this is an example of a continuous measure. The tests that he has, or the questionnaires that he administered, would ask you, how do you like ice cream? Or do you like ice cream? And You would say strongly agree, strongly disagree, or agree, or neutral. You had that line of ranges there that would indicate the intensity of how you felt about that particular question. And that would be a continuous measure. Now, attributes are the things to measure. They are characteristics or features that pertain to that object and person or issue. And then you have index measures. These assign a value based on how much of the concept being measured is associated with an observation. And they give you the example here of social class. Now, social class may be measured along the lines of education, occupation, and where you live. Those three things put together would be an index on how you would assess economic prosperity or social class. Now, a composite measure is pretty much the same thing, but it's a little bit more involved and a little bit more complex than just a simple index measure. For instance, a composite measure may ask, as they say in the textbook, they may ask a salesperson about his or her satisfaction, and then they would measure that satisfaction with questions. How satisfied are you with your job? How satisfied are you with your territory? How satisfied are you with your budget? And so forth. How satisfied are you with the opportunity your job offers? So it's a more in-depth type of measure here, index measure, but you're still looking at a combination of elements that make up a whole measurement. Now, a summated scale is a scale created by simply summing or adding together the response to each item, making up the composite measure. And if you see here in the textbook, they show you this on page 300, where you strongly agree, disagree, and so forth. And here you just add up the responses, and then you can average those responses. For instance, here in Exhibit 13.6 in the textbook, they ask a question and a person disagrees, and the next question the person was neutral. The next one was disagree, the next one was disagree, and the last one was agree. And you just sum all of those values up to come up with the computation. And from there, that's what you would derive as the measurement. Now, reverse coding means that the value assigned for a response is treated opposite from the other items. And so here you have the changing value of a response to a scale. So it's opposite of the original value. For example, in the textbook tells you a scale from 1 to 5 is reversed, so that 1 equals 5, 2 equals 4, 3 equals 3, 4 equals 2, and 5 equals 1. And this is done, as the textbook indicates, so negative items in a scale are scored in the same direction as positive items. So you're not biasing your responses and so forth, and everybody has a more equal chance of being adequately measured. Well, today we considered just the opening part of Chapter 13, and we'll come back and finish that up. But today we looked at what measurements are, some of the different types of measurements, ordinal, nominal, ratio, and so forth. And we took a look at a little bit about scaling. So you see how complex measurements can be, but they're oftentimes used in pretty much just any type of way when it comes to research. So just understand the fundamentals of it, how they're used, and what they try to accomplish, and you'll be on your way to being able to use these measurements. That's all we have for today, and until next time, God bless you and have a good day.